Well, hey, what's up, everybody? Excuse me, I got something stuck in my throat. Sweet. Well, we got a good crew today. How's everybody doing?
Good, thank you.
Cool. Let's see here. Is anyone here from Career Karma by chance? Just curious. I know you, Eric. How's it going, man?
What's up, Ben? How you doing?
I'm good.
Good. Good to see you. It's been a minute.
Yeah, you too, man. Glad you could join.
Yeah, it was a slow day today, so I figured I'd take some time off.
Nice. Well, today should be fun.
Yeah, looking forward to it.
Cool. Let's see here. All right. So I think let's just get started. So today is a little different than I think other days. So for those of you who don't know me or haven't been to these co-talks before, my background, I've been a software engineer for about 4 years. Well, technically two of those years. The other two I was teaching. But my background prior to becoming a coder was actually in philosophy. That's actually what my degree is in, which is on the surface seems completely unrelated to such a technical field like coding. But one of the cool things, what's up, Alexander? I just saw your last name and I was like, oh, I know you.
Hi, man. What's up? Nice to see you.
Good, yeah, it's good to see you. So anyways, yeah, so my background is actually in philosophy. That's what I studied in college. And so one of the things I am really, I guess, fascinated by as far as coding goes is kind of like the structure of it, like the actual art of coming up with solutions and not only that, but coming up with elegant solutions and ways to make code not just work, but also be easy to interact with and deal with and share with people. Because that is a whole other aspect that in boot camps you don't really ever get a chance to really dive into some of that stuff, and it's not really boot camp's fault. It's the fact that there's so little time to get through all these concepts. But to really become like a master of this stuff, not that I'm a master. I've just been doing it for a few years, but the key, of course, is just time and practice. But I think there's a few general principles that if you adhere to them, or if you at least are mindful of them, it will dramatically improve how you code. Because what I've found is part of what's fun about coding to me is the actual like task of coding. I know that sounds like weird. Like it's coming up. One part is coming up with the actual solution or solving a particular problem. But then there's the actual like experience of coding itself, like the actual like you're sitting down and you're trying to come up with ideas for how to move forward. And that part is where there's all to me, that's where art and philosophy and technical problem solving all kind of come together. It's in like that moment where you decide uh, how you're going to approach something, or how you're going to uh, where you're going to go from there, how you're going to organize your code, how are you going to organize your files and stuff. And sometimes if you get too abstract, if you get too hung up on certain details, you get stuck. But then sometimes if you go too head on and you just try to just rush through it, you then hit a wall where suddenly you realize that the way that you did it was completely wrong and that you have to go back and rewrite pretty much everything you did. And so finding that balance between just coding the damn thing and planning it out ahead of time is kind of where the magic happens. So today my goal is to just kind of go over some general, I guess, principles that I follow in my daily life, or I try to anyways, that will hopefully help you guys in your day-to-day coding be more like efficient at getting things done. What I've Coding to me is the art of managing complexity. At no particular time when I'm working on some giant enterprise level project do I have the entire network of functionalities and stuff in my head. It's just too much. There's too much information. Our brains aren't designed to be able to hold all this info in our head at a time. So we have to be clever about how we engage with it. So how we engage with it is kind of the focus of this episode. So before I get started with some examples and stuff, does anybody have any questions or comments? Again, my background is in philosophy and stuff, and so I was hoping this would be more of like maybe like a discussion of things, rather than me just yammering on. But so if anyone has any questions, either send a chat or just speak up. So does anybody have any questions before we go into it?
It sounds cool.
All right. So, all right. One of the first things that when I'm building an application, for example, and I'm going to bring up a project that I recently did just for fun. But one of the first things I think of when I'm building an application is I try to zoom out as much as I can. And I think like, okay, well, what is the fundamental thing that I'm trying to do? So the example that I'm going to do right now is we're going to build a stupid little calculator, which I know is lame, but it will demonstrate some ideas that I hope are important. So so as we get started, we have to think about, okay, top level, what exactly is going on? What are we trying to solve? So in this case, we're building a calculator. So the idea is, okay, we need to be able to a calculator, when you think about it, is just an interface that lets you type in numbers and operators in some combination, and it will output a solution to that operation, or output. It'll output a result of that operation, right? Whether it's a plus or a minus or whatever. So, okay, cool. Now we can draw pictures of what this might look like. We can, and I'm not going to make this look pretty by any means. I'm going to try to use as little CSS as possible, because the goal of this is for structuring logic as opposed to making things look pretty. Except that's the focus of this today. But anyway, so in a nutshell, that's basically what it is, right? You take input from a human, you perform some operation on some numbers, and you see the result. Pretty simple, right? Or it seems simple enough, right? But what I've found is, especially beginners, once they um, once they get that initial seed in their idea, they tend to just go right in, just dive right in and just try to code the whole thing all at once. and I do that too. I've done that many times and regretted it because, well, what happens when you do that? Anyone have a experience they want to share?
Well, you get lost. Like your variable names stop making sense and your functions get convoluted and they're not operating optimally. And, you're doing redundant stuff that, doesn't need to be done in that use case necessarily.
Exactly.
Yeah.
Yeah, there's some keywords there, redundant, and that's the big one. Redundant is you start doing things over and over again. You start rewriting code that you have in other places. It just falls apart. It's very quickly. It's like building the engine and the frame and the seats and the driving wheel all at the same time without consulting each other. Like you're just trying to get it out the door, and it falls apart very quickly. So so at first you have to kind of break down your idea into several different components. We've got our umbrella, right? We know that we have this general idea of what we know a calculator is, or what a calculator is. So for now, what we're going to do is I'm going to build just a little template. So we're going to have our we'll have our input at the top, and then we'll have our let's see here, and in here we'll have our we'll have our numbers. Cool. And then we've got our buttons or operations. Okay. So I'm going to run this guy. Okay, here's our sweet calculator so far. Beautiful. It's just amazing. So now what the most important thing to be able to separate in your mind, and the reason why I'm calling this the art of abstraction is because this requires a lot of thinking abstractly. Like there's no definitive place in the world where this happens other than in your mind. You have to think to yourself, okay, I have data on one hand. I have like actual data numbers that I'm working with. It might be the number 10 and I might be adding it to the number 20. I might be subtracting 10 from 50. There's all these like specific things we can think about, but there's another level of that on top of that, which is it doesn't matter what the numbers are. It's what actions am I performing? What does my template look like? So the first thing I do when I'm building out like a web application or something, and this is specifically web development, but the same principle you could argue the same thing with other languages and other frameworks and stuff, PHP, etc. With this, there's this idea of a template. A template is this like thing that is it's a logical structure that is devoid of data. Data gets injected into a template later. It's just like a blueprint for a house. The blueprint is not the house, right? There's no, you can't live in the blueprint. You can't bake cookies in the two-dimensional square on a piece of paper. That's the kitchen. The template just, it's devoid of data. It's a logical structure, but it doesn't have data. Does that make sense? And so when you're creating a template for something or an interface, you're defining how something looks, but you haven't decided how it behaves yet. Because you can't even do that yet because there's no data. You can't manipulate something without data. Data is like the lifeblood of a program. Whereas a template or a structure is just like kind of it's the necessary underpinnings that allow the program to work, but you're not actually doing anything until you inject data into it. So it's kind of like fuel in a car. You need the engine, but then you need fuel. You can't work the car without both of those in tandem. But you need the engine first. So that's what we're going to build first. So we're going to design this little template here. And notice that I'm not paying attention to event listeners, logic, anything. This is all just how things look. I'm taking it one step at a time, which is I want to minimize the load on my brain as I'm coding. That's kind of the key of not going insane. So, all right, we've got our input over here and then our div. So we'll probably have, we'll have a set of numbers here. Let's do we'll do a div there, and then we'll do some spans with our numbers. So we've got 1, 2, probably should do a 0 in there. So we'll just do our digits. Actually, I just realized in a normal calculator, 0 comes after 0 comes after 9. Okay, cool. Okay, and then so let's see how that looks. Okay, cool. Oh, and you know what? Let's make these. Let's make this a button. Okay, cool. Sweet. Okay, and now we need to have our operations, right? So now the standard ones are plus, minus, multiply, divide, which we'll just start with. We'll start with those guys. So we'll have a plus, we'll have a minus, we'll have a divide, and we'll have a multiply. You could either do X.
I have a question. So
Yeah,
this is
go
like
ahead.
this is the template of our application, right? You're setting up the template.
Yeah, we're just setting up like how it should look.
That's like, I used to call it like a skeleton.
Yeah, that's
Correct,
a good way to
right?
put it too. Sure.
Yeah. And then you add the functionality.
Yeah, and then we add the functionality into it.
And this approach is like this is abstraction itself.
Yeah, because like we know. So I guess when I'm talking about an abstraction, what I'm talking about is a mental representation of the program. So I'm thinking of the program in it has several different components to it. And I'm not talking about like React components. I'm not talking about components in that sense. I'm talking about in just like the general sense of my program is a combination of how it looks, the thing that I actually engage with as a user, but it also is built up from logic. So the logical underpinning, so the behavior itself, the logic governing the behavior. And then you have the actual data. So the data is stuff like, the actual inputs and the outputs of the program. So you can, in general, no matter what program you're building, you can usually categorize it into those three places. even like a really complex program, like Facebook, for example. Now, there's vastly more categories you could break that up into, but I would still argue that at the end of the day, you could still reduce it to those three things. You've got your data, you've got your template or your interface, and then you have the logical instructions for how it should behave. Now, those can be, of course, incredibly complicated, but by separating those in your mind, you can tackle them independently. And my whole, like, I guess, theory of coding is to be able to uh, write small programs in isolation and then build them on top of each other. And it sounds a lot, it's easier said than done, because once you get into this idea of things having dependencies and stuff like that, it can be tricky. But if you at least can attempt, or at least have that idea in your head, you'll be able to manage the complexity of your program a lot easier. And there's not really an order to do these in, and I would never say that this is like the correct way or the best way to do it. I just think it's helpful in my experience.
I think, yeah, this would be, I use this approach. I always use this approach without naturally, because I couldn't handle it any other way, right? I used, before building something, I would have to set up a structure, the skeleton I would call, like no functionality, but
yeah,
just to see what am I going to have on the screen, and then slowly add the functionality to each component.
Right.
But yeah, I think this is the right approach.
Cool.
Let us see.
Awesome. Well, sounds like you have a natural. You're a natural then.
Thanks. Yeah, I mean, I couldn't find any other way to start an application, because then it can get really messy, right? So
totally.
So when I didn't know how to start something, I would just start this way and then build on top of it.
Right. Yeah, and I think this is generally a good way to go.
But are there like are they programmers who just start and then start some other way of creating something?
Probably, yeah. I'm sure there's people. I'm sure that there's like people that are just like total geniuses and can just like do all of this at once.
Okay.
I'm not one of those people, so very few are, I think. But I'm sure that there are other. I would really be interested to know like what other strategies other people have, because I know that this isn't like the only way to do it. And plus, this is kind of unique to web development. When you have like an actual screen, like a graphical interface,
UI, yeah.
When you have an UI, yeah, it's that's a pretty unique part, or that's a unique type of program. Because obviously, if you're building databases and servers, you don't necessarily have a UI, and so you kind of have to. So your program, or the way that you think about your program, is actually probably more abstract than doing something like this. You don't even have anything to visualize. You can like draw graphs and maps and stuff, but there's nothing to actually look at. So this is one of the benefits of web development, especially for like people who are like very visually oriented. This is a good place to start.
Awesome.
Yeah, and one thing that I will note is you should never think that your program is set in stone. Like, once I'm done with this template, you'll find that as you go through adding logic and stuff, you may find that, you know what, I didn't anticipate this thing, so I might have to go change my template a little bit. And that's okay. That's totally fine to do that. You're never going to write code the first time and have it just work perfectly. It's just not going to happen. I guarantee you. It never happens. And if it does work, then you probably did something wrong. So, all right. So back to our template. So, okay. So we've got our numbers here. We've got our operations here. Now, and again, I'm not going to waste too much time on CSS because that's not the point of this. So now there's a few ways we can look at this, and it depends on how we want to go about this. So what I'm doing now is I'm creating this. I've got an input where I can, theoretically type stuff. I should also be able to, click numbers, and then maybe click one of these guys, and then do another number, and then hit equal and see something. So the question is, okay, how do we want to manage our inputs, and how do we want to manage our outputs? So now in most modern calculators these days, it all kind of just happens in one place, right? You hit you enter your number in, you see the thing, you hit a minus sign, you see the minus sign, and then you hit another number, and then you'll see the thing, and then when you hit equal, you see the answer there. So let's try that. If we decide that we want to put another input for something else, we can do that too. It doesn't really matter. Okay. So now we have to start thinking about, now that we have our template, we have to start thinking about behavior. Now we don't but we don't have to worry about data yet. Okay, we don't have to worry about specific numbers yet. We're still very much in this abstract phase where we're thinking about, okay, what is the general behavior? So if you're thinking from the user perspective, the idea is you can click numbers, you can then click an operator, and then you can click numbers, and then you can hit equals and see your answer. So that tells us that there's maybe like a 3-step phase here, which is input, operator, input, output. I guess that's 4 steps. There's 3 input steps, right? Where you type in your number, you click your operator, type in your number, and then you see your output. So there's really only, or the browser only gives us one way, well, 2 ways really to interact with this thing. One is I can type numbers, and the other is I can click buttons, and that's it. So that actually, by realizing that actually limits your options a lot. And sometimes having limited options is actually a really nice thing, because then you don't have to, you don't get lost in all the possibilities. So we know that when I click a button or I type in something, that's the only way that we can trigger any sort of logical behavior in this thing. So that just tells me that, okay, well, I need to handle some sort of logic when I'm clicking on a button, and I need to handle some sort of logic when I'm clicking on an operator, and I need to click on some sort of logic when I type into an input. That's it. So now it's just a matter of like organizing that into like some meaningful process. So we have to go from these options of clicking and typing into coming up with an actual like workflow. So there's a few, I guess, limitations that we kind of have to work around, which is, first of all, you can't just click on an operator if you've typed in a number, or if you haven't typed in a number yet, right? And clicking equals before you've done the full expression, 2 plus 2, for example, if you've only hit 2 plus, then hitting the equal button probably isn't going to do anything, or shouldn't do anything, or it should at least we should at least be able to anticipate these situations. So it's good to just kind of keep that in your mind, is to be like, what are the possibilities here? In a perfect world, users would simply do this right. They would enter a number, hit an operator, enter another number, and then hit equals. And then everything would be great. But that some people are going to forget to put an operator, or they're going to try to click multiple operators in a row, or they're going to hit equal sign prematurely, et cetera, et cetera. So for simplicity's sake, today we're just going to assume that you're only limited to 2 numbers and you're only limited to 1 operator. But we'll talk about some ways that you could maybe handle those kinds of situations later on. So first thing first is we've got to come up with a way to manage clicking on these buttons and entering in inputs in various orders. Okay, so let me link up this JavaScript file. Okay, so we have to first of all kind of come up with a way of identifying these things that we're clicking on, right? So what we're going to do is we're going to define we're going to use some classes to kind of organize the different types of buttons that we have. Okay, so we'll give this input the actual, I'll call it the view. I don't know, for a lack of a better word. I think view makes sense. That's where we're viewing the numbers. Here we'll call this the digits, and then here we'll call these the operators. Oh, we got more people joining. This is sweet. We got a good crew today. This is awesome. So there we go. We've got our digits. We've got our operators. Okay, cool. We can also, it might benefit us to also give these buttons some values. Okay, so these are the things that so we got 2, we got 3. This is the only tedious part. 5, we got 6. 7, we got 8, we got 9, and we got 0. Okay. And then here in our operator section, we could give these IDs, we could give them names. Give them a name. And we'll say plus, we'll do minus, divide, multiply, and finally, we'll do equals. Okay, so the reason why I did this is just to kind of give our elements so a way of identifying, what they are and what they do. So does anybody have any questions up to this point? Cool. All right, so now is the tricky part. We are staring at a blank file. And this is the scariest part, I think, for anyone that's a programmer, is where the hell do I start? So now, okay, we know that, so we know that there's a few things that we can just start out right off the bat. We know that we need to be able to identify those elements that we just created, or labeled, I should say. Okay, so why don't we at least start with grabbing those guys? So we'll get our operators, which is document dot query selector, and we'll get our operators. So that's our the wrapper for the operators, and then we'll get our digits. Cool. And then we'll get our view. Oops. And oh, no, that's an ID. So let's just get that by ID. There's only one of these, so it makes sense to get this by an ID. Oh, and these need to be class. Yep. Okay, cool. All right, so we got our operators, we got our digits, we got our view. Okay, sweet. Okay, now we have to think about how these behave, right? So let's think about what happens when we click a button. Okay, so whether it's this guy or this guy. Actually, let's worry about these guys. Okay, so when we click a digit button, so what I'm going to do is I'm going to write a series of I'm going to write a function called handle click digit. Because we're not thinking about everything all at once right now. We just want to think like, okay, what happens when I click on a digit? Well, what are the situations? What are the possible scenarios that we might encounter? Well, one is we may have already clicked or entered some digits prior, right? We may have clicked an operator prior. We may have not done anything yet. So let's just kind of in our head remember like, okay, there are some possibilities here. So either it's our first entry or it's part of, let's call it part of first entry, meaning like, you know, we could be adding a digit to something that's already there. We could have already selected an operator, or this could be part of our second entry. When I say entry, I mean the number that we're adding, or not adding. Sorry, the number that we're typing that's going to be either added to or multiplied or divided or whatever to the first number. Does that make sense?
Yes, it makes sense.
That's cool.
All right, so now this may seem a little overwhelming. Like it's like, oh man, like we have one function that somehow we have to handle all these things. But that's okay, because again, we're going to tackle these one thing at a time. So what we have to think about is, okay, what is our, what data structure are we going to use to represent where we're at in this process? And there's a lot of different ways to do this, and how you decide this has a lot of implications for, you know, how easy it is to grow your application and scale it and build it and whatnot. So we have to think about, like, okay, what are we going to use to represent where we're at in the process of either adding, subtracting these numbers together. So like we said earlier, we know that there's a first number, we know that there's an operator, and we know that there is a second number, right? First number, operator, second number. So we can use a data, we can use a data structure to try to represent that. So what I'm going to do is I'm going to call this, let's call this, oh, what's a good name for this? I'm going to call it data for now. If I come up with a better name, I will. So we're going to represent first entry, second entry, and then operator. Oh, that's not. Yeah. Semicolons and objects. Okay, so this is maybe one way we could think about it, right? We can also think of some other ways. For example, so one, I guess, limitation of this is that for every new entry we'd want to add later, I'd have to like manually do this, right? And then like I'd have to come up with a way of being like, okay, well, what about another operator? You know, like this might get unmanageable. So we could maybe think about a different way of doing this. Suppose we do, instead of that, we do like an array where it's just a sequence of number, operator, number, etc. That way, it's extendable, meaning like we're not limited, or we're not limiting ourselves to just this one little bit of functionality. So suppose we do something like this, where we have data, which will eventually be populated with something like this, where we have something like that. Or in fact, let's call this. Now there's a lot of ways we can think about this. Why is my formatter not formatting? Okay. I don't know why this is my formatter's not formatting. Okay. So check this out. We could think of it like this, where we have some number, or as we're typing, we can add numbers, or we can just add objects to this array that represent the thing that we're doing. That could be cool. And in fact, And again, I'm not writing, or again, we would start out as empty, of course, because the program when it first starts, there's nothing there. But check it out. We can imagine as this grows, and again, this is part of that abstract thinking where it's like, okay, let's pretend that we have this actual value, right? Where these can then just get, every time we type, we can get a new digit, perhaps, right? And then we can get an operator at some point in this chain. And then after that, we could get more digits, right? Which would look something like this. And so then what we can do is add more. So let's just add one more just for good measure. So I don't know, we'll say that's a 6. Let's go in order. So there you go. So this is kind of cool. This structure allows us to arbitrarily add as many digits and operators as we want. That's pretty cool.
This is cool.
Yeah. So,
and then you would loop over your data, and then if it's digit, you add it and store it. You create the first number.
Yeah, you just concatenate things. And in fact, these would probably just be strings to keep it simple. But again, we're just kind of brainstorming right now.
Okay.
But yeah, you're right. We simply, when we click on our equal button, what we're really doing is now we need to come up with ways to interact with this data structure, which is just an array. It's just an array of objects that contains the type. It's just some metadata about what is contained in this object. And then we have a value, which represents, the thing itself, the actual data.
Yeah.
Makes sense. So we can write logic. Sorry, go ahead.
So, sorry.
No, go ahead.
I just like the approach. I've never seen how a calculator works.
I mean, there's lots of ways to do it.
Lots of ways
to do it.
It's really cool. Yeah. Sorry.
Yeah, and there are some limitations with this too. I would imagine. But this is a good starting point, I think. So you're right. So we are able to, if we're expecting a data structure that looks like this, then we can think about all the ways that we need to interact with it. Okay. And it's actually pretty simple. We can either add digits or we can add operators. We can remove operators and we can remove digits, right? There are some rules, though, that we're going to have to kind of be aware of, such as we can't have 2 operators in a row, right? That's going to be something that we'll have to enforce, which is we can't have 2 operators in a row. And there's theoretically a limit to how large a number can be. We won't worry about that today, but it's something to keep in mind. This can't be like 500,000 digits long.
But if you have 2 operators in a row, can we just choose the last one?
You could, and you could think of there are some ways that you can. We have to come up with ways of handling this situation. So how we deal with that, we'll cross that bridge when we get there. To me, it would seem like we shouldn't allow an operator to be added to begin with if there's already one at the end. That would be my that would probably be my argument.
But then you need a backspace option in case they messed up.
Sure.
But does a real calculator take, if you press, let's say you want to add 2 numbers to 1 plus, and when you change your mind, you want a minus, and you press the minus, would a real
Oh,
calculator
I see what you're saying. So then it would just simply override it.
override?
Yeah, that could be that I actually like that solution better. Now that when you explained it that way, I actually like that, because then that means that if I click on an operator, I go, oh crap, no, I don't want to do a minus, I want to do a plus instead. Then if you click the plus sign, it will then just replace whatever
Which
the operator is.
I just tested that on the iPhone calculator, and that's how it works.
Does it? Beautiful.
Apple
There
does
you
it.
go.
It's got to
There's
be
some-
good.
I'm glad we got some UX testers here. That's a great point. I'm glad you bring that up. So yeah, so those are kind of some those are the ground rules we'll set up ahead of time, which is we can't have multiple operators in a row. We'll just override them if necessary. And also, we can't add an operator if there isn't at least one digit prior. Make sense? So,
Unless that
okay.
operator is a minus, and then it becomes a modifier.
Oh, you mean like for negative numbers?
Yeah.
Sure. So these are all really great points that everyone's bringing up. So
What I would like to ask, if so, you want to restrict what would go in the data array, right?
Yeah, we basically we just have to define rules for how certain objects are allowed to be added to this array.
Okay.
And removed from it. And these are all really great points. So the modifier, for example, maybe we'd want to handle that. I'm not going to handle it today, but it's something that would definitely be important. And using this data structure, you can think, how might we approach that?
What about, my first thought was we let everything go in the array and then just work the logic out. So if we find array 0, an operator, we move to the next item.
But suppose I do 6 plus negative 10.
So
then it might look weird, because we might have something that looks like this. Right? So we might have to have something.
Well, you start with track. So if we have numbers in a row, we create. So we check the first item in the array. If it's an operator, we're not going to use it because it's invalid, right? You can start an operation. You can operate. You need a number. So we jump over that item and we go check the next one. If it's a number, we start creating. If it's a digit, we start creating our number. And the first operator we find, we again start a counter, and let's see the next item. Is this still an operator? If it's an operator, then we overwrite the first one, the one we found. So it's just
right, but this is a case where we actually do want potentially 2 operators in a row. Where
and if you start with an operator, you usually would just use the last answer that you use on the calculator.
Exactly.
Right, and then there's that case as well.
Calculators are hard.
So you can see how this can become pretty complicated.
Just what I wanted, I thought we're not going to restrict. We put everything in the array, and then we work with the data. We write. So
you're saying that we add things to the array without any
restriction,
any abandon whatsoever, and then afterwards we just try to parse it.
Yeah, just work it. Yeah, just parse.
We could do that. We could make it so that but then we'd have to write a parser, and those rules would have to be applied in the parser as well.
Yeah, a lot of logic. Yeah, that was my initial thought. So
yeah, and we will essentially have a parser. I would argue that we'd want to simplify our parser's job as much as possible, by at least laying some ground rules as far as what we can add to the array.
Okay.
So we could do something like this, where what's nice about this pattern here is that we're not stuck with just digits and operators. We could have a type called a modifier, for example, which would then be like, okay, well, if I've got a modifier, then whatever I have after, whatever digits are after the modifier, we'll just make sure to, modify them doing the, the negative, for example. This isn't the only way we could do it either. We could also have a separate variable called like current modifier or something. We could come up with some way to apply a modifier to a certain number. But to me, this makes the most sense because it allows us to follow our same pattern. But the beautiful thing about this is that we don't have to, we can be aware of these things ahead of time, but we don't have to think about it all at once. We're going to start with a very basic pattern, and since we've created this data structure this way, it allows us, I think, enough flexibility that in the future, as we decide to add more of these features, it shouldn't be too difficult. And that's what I want to emphasize here, is that we're creating this in such a way so that it allows us to handle these kinds of seemingly left field situations. So we're going to keep that in mind for now. We're going to have types, and we're going to have digit types, and we're going to have operator types for now. But again, since this is we're starting our data structure from scratch, or our program's going to start empty. We're just going to start with the empty array. So now we have to think about, okay, when I'm typing, or so let's do the buttons first. So when I click a digit, what should happen?
Event listener?
Yeah, we need to trigger an event that then grabs the value from the button and adds it to our data. And not only that, but then we need to be able to display. The relevant information in the little view thing, right? So let's start with. So a handle click digit. We know that this function, because this is our handler, this is going to be the function that triggers when we actually click the button. Now, I haven't actually added this event yet, so let's go ahead and do that. So we know that we have to add this thing to all of our digits. Okay, so we'll just go ahead and do that. So we'll just say operators dot
Digits dot.
Oh, sorry, thank you. Digits. I think children has a for each thing. So we know that this is our digit button. And then we'll just say button add event listener handle click digit. Let me just make sure that this is actually, get my debugger up. There we go. So it's 5500. Go. Okay, here we go. For each is not a function, so I've got to do. I forget if maybe child nodes has it. If not, I'll just turn it into an array. Eric, at the top of your head, do you remember if child nodes has a for each?
I don't. Look it up.
Here we go. All right, it does. Cool. So for each, so if we look at our button, oops. Oh, the problem is that's, I'm just going to turn them into an array. There we go. Okay, so as you can see, here's our, we're looping through our digits, and then for each button, digit button, we're going to grab its value, which we can see that it's down here, right there. Check it out. So we're on our first iteration. So we got our first value. Cool. We'll go through again. Beautiful. Okay, so notice what I just did was I just dynamically added an event listener to all of our buttons. But the other thing I want you to notice is that I haven't done any logic yet. So I've separated out this idea of, I know that every button has to have a listener. There's no way around that. So I just added them. We can worry about the logic later. So that's what we're going to do now. We're going to worry about the logic later after I've already added the listener. And this is where we can take care of our logic. So we know that our when we click on a button, we know that this function is going to get triggered. And just to prove that to you, let's put a breakpoint here, and we'll click on the number 2. Oh, I forgot to add the type of. There we go. Okay. Boom. Okay, check it out. I just clicked on the number 2, and here we go. Here's our button, and again, we can grab our value and whatnot. So this is cool. This allows us to grab the value from the button and add it to our data. Okay. So the question is, like, can you think of any like conditions under which we shouldn't add a digit to our array? The only one I can think of is limiting the number of digits per number. But that's we don't need to worry about that right now. But that's the only thing I can think of.
I think the operators are the tricky one, not the digits.
Yeah, the operators are the only one that's kind of tricky. So now what we want to do is okay. So let's think about, again, this idea of how do we abstract this to make it easier on ourselves. Now, I could write all of my logic for adding digits here, but does it really belong there? Does this logic actually belong in this handler? I would argue no. I would argue that the actual data manipulation belongs in a separate set of functions. The whole purpose of the handle click is just to simply delegate. And that's the job of an event listener, is to delegate, in my opinion. It's to, oh, an event just happened. Here's the event information, which is this guy right here. Here's the event information. This thing just happened. Here you go, guys. Do what you got to do. I'm gonna offload the work onto you guys. Here's the raw material, but now you guys can go deal with the actual logic handling itself. So why don't we add another function called handle digit. And the digit takes, you know, whatever our digit is, and does whatever we need to do. So in this case, we'll just say, okay, here's our, and in fact, I'm just going to make this a little simpler. We'll just grab our value from the button, and then we can simply say, okay, handle, there you go. Do what you got to do, whatever it is. I don't care. And all of these rules that we have to be aware of, we can worry about somewhere else, because it's not the job of this function to care. Its only job is to just offload the data from the actual click event to the things that to the functions that are actually doing the work. So here we can decide, you know, how do we handle this? Does that make sense, everybody? Okay, cool. So what we can do now is, for now, and again, this is all, there's no shame in realizing you did something wrong and going back. But for now, I think this is a fairly sensible. So here's our value, and there you go. So now what we can do is we can verify that when I click on this button, it's going to add it to our data array. Okay, so let's see if that happens. So we'll go ahead and put a breakpoint here. Okay, let's click on the number 2. Sweet, and let's look at our data on the side here. In our script. Hey, check it out. There it is. Sweet. All right, so it seems to be working. That's exciting. Let's click a few of these guys, and then we'll put another breakpoint, and then just do one more time, and then we can just verify that, hey, we've got several digits. Okay, sweet. That's pretty awesome. Okay, now of course, there's something obviously missing, which is nothing shows up in our little view screen here, right? So we got to think about that. How might we handle that? Well, we've got our digit thing, which is pushing our data into so this guy's doing its job, which is to add information to our data array. But it would also seem that when we click on a button, when we click on our like digit button or whatever, we should also see something appear. And so now you could argue where that logic belongs. Well, does it belong here? I would argue no, because this is specifically just for dealing with data. I would argue that it would go in here. I would say to update the view. I'd say handle your digit update the view would be my argument. And if we were using a framework like Angular or React or something, it would be a little, we wouldn't have to be so explicit about this. It would kind of do the rendering based on our data to begin with. It's one of the benefits of those frameworks. But in our case, we have to not only manage the data, but we also have to synchronize it with what we see on the screen. And I would argue that those are two separate things. They're very different things. But they both need to happen at the same time, namely when we click on a button. So I would argue that we would then say update the view. And what we can do is write a function. And notice I'm not creating separate files or anything yet. I'm being fairly loose about this until we get to a point where maybe it would make more sense to start breaking these up into files and stuff. But I think what's more important is separating our logic in a sensible way. Because you can always, if you do that to begin with, then it's very easy to just move things around as needed. So here's the thing. Our update view function needs to be able to show essentially the most recent thing that's happened. But not only that, it needs to know whether it's a number. See, Alex, we need to know whether it's a number, like, you know, a bunch of digits strung together, or if it's an operator. So we kind of have to work backwards through the data and see, you know, well, what's the last thing in the list, and then work backwards. And what's nice about this is that as we get more complicated, we can always update this function. What's nice about this is that this is only happening in one place. So if we find a snag in the way that we wrote this, at least it's isolated to this one particular spot. So for now, let's think about how we might deal with this. So I would argue that the first thing we do is check the last element of the array. Okay, so if it's an operator, we'll probably want to show the operator. If it's not an operator, then we want to show the entire number, which would mean either the number starting from the very last one and going all the way back until we either hit the beginning of the array or we hit another operator. And maybe there's modifiers and stuff that we can add later. Okay, cool. We don't need to worry about that right now. Let's just, for now, we know that we're dealing with numbers or digits and operators. So let's just start with that. So let's grab the last element. So we'll just say data, and then we'll get the last index, which of course is data.length -1. Okay, so we've got a couple options. So since we're checking a type, which is going to be either digit or operator, it could be modifier, it could be a number of things. I prefer to use a switch statement as opposed to an if. So in the case that it is a digit, well, like we said, we're simply going to loop backwards until we find, we're going to loop backwards until we find either the beginning of the array or an operator, and we're just going to snag that bit of the array and then concatenate them all together. And we could write some helper functions in there to do that. So let's write a function called Aggregate Digits.
So all we need to know is where to start from and where to end from. Okay, so we'll do our start and our end index. And then we can simply just say, we'll go through our data. Here's our output. And then here is our, we'll call it element. We know that this is going to be a string. So we will just say return output plus, and then element dot value. Okay, so I just want to point out something that I did here is that I just wrote a little function that just adds to, or that just adds up all the digits, or concatenates all the digits together from some arbitrary index to another arbitrary index. Rather than trying to write a for loop and crap in here, I abstracted that functionality into a function. So now it's just a matter of finding the start and end index that are important. And so how do we find that? Well, we can simply just start from where we're at last and go backwards until we find a non-digit type. Easy. So let's just so I could write another function. Find find non-index. So we'll start from, you know, from there. Let's go like this. We'll go from our start, and then we'll just go until data I is not equal to digit. And we'll just subtract. And we'll just go until we either find one that's not a digit or that it's empty. So, or I is greater than, or sorry, I is less than 0. Okay, that'll prevent us from, you know, breaking if we get to the beginning of the array. Okay, go from the start, check if there's a digit or if we're to the beginning, and just subtract. And we'll just get a number from it.
You're going from the end though, right? That might be a little confusing.
Yeah, from the end, exactly. And we will then do, let me think here for a second. Actually, you know what? There's a simpler way of doing this. I'm just going to do this. Go until you're 0, and then we'll just say if data I dot type is not equal to digit, then we're going to return the index right after it. We could also do a check where we say, you know, if the one prior to the element we're on is equal to or is not a digit, then return the one we're currently on. There's, you know, different ways to do it, but they're both logically equivalent. So the idea here is all we're doing is finding a non-digit, or all we're doing is finding the index, the first index
of the digit that we want to start aggregating from. So we know that we're on our last one. And then what we're going to do is, so we know what our view is, it's up here. So we're then just going to say view.inner, or view.value, because it's an input. We're going to say view.value is equal to, we're going to aggregate the digits from find non-digit from the starting point, which is the end of the array, to that one. So that gives us the beginning of the number to the end of the number, if I did this right. And then we should see, yeah, if I did this right, that's the key. So if I did this right, we should see the input update with the digits that we're adding. Let's do a quick sanity check here. Oh, obviously we need to update. We need to call our update view function. So there you go. Doesn't take any inputs. It already has data in scope. Okay, let's see what happens. Let's see what bugs we get. Oh, my breakpoints are still there. Okay. Hey, check it out. Okay, it's working. Sweet. That is exciting. Okay, let's just for fun, let's I'm going to put another breakpoint there, and when I click on a number 5, if we look at what we've got, 4 3 2 1 6. Okay, that's awesome. The one that I just pressed is a 5, so that will get added to the array. There it is. Beautiful. Awesome. So it appears to be working as planned. That is exciting. And let's see what happens when I click on an operator. Hey, nothing, because I haven't written that logic in. But notice how this is actually a stable app, right? Like it's not complete, but it's stable. That is something that for beginner coders especially, I highly recommend dealing with errors as they come. Don't try to write your whole program and then go back and try to debug the whole thing. It's a nightmare. Try to write your code in such a way that you can just achieve these little milestones. Kind of like what we've been doing today, where, you know, my calculator isn't a calculator, but it's stable. It still at least works to the extent that we've added logic to it. It's not in this weird, like, broken state where I can't even use it and I'm relying on adding more and more logic for it to work. Like, we've built this in such a way that we can piecemeal these milestones one step at a time until we get to our desired result. So I highly recommend trying to code this way. I know that it's way easier said than done, but it's just something that you want to just put in your head. If you find yourself being overwhelmed by errors, or find yourself overwhelmed by the amount of complexity or logic that you might have to do, it's probably a sign that you're trying to bite off too much at a time. Even experienced senior devs, and Eric, you can probably speak to this, you're not thinking of the entire program all at once. You're thinking one little bit at a time.
Right. And also important that when we think about that next little piece that we want to add, it's not going to break what we already built.
Yep. Yeah, that's a great point. Yeah, everything that we're adding here is not breaking what we currently have. We're just kind of, it's kind of like building a cake, maybe. I don't know. I'm not a baker. I don't know if that's a good analogy. Anyway, so where were we? So let's see here. Oh, and you know what? I just realized something. I made a mistake in my aggregate digits. I'm not using start and end. I meant to do slice. Right, because otherwise we're reducing the entire data. We want to obviously we only want to aggregate the ones that we care about. So what I'm doing is I'm slicing out the values that I care about. And again, that should be +1 because slice is non-exclusive, meaning that it doesn't include, it goes up to but not including the array or the index that you provided. So that's just a fun fact. So let's just double check something really quick, make sure everything's all good. Oh, what did I do? Always check your dev tools. What happened? Sometimes. Okay. There we go. Okay, I don't know what happened. Okay. So it should get.
I think find non-digits is only returning one item and your aggregate digits is expecting 2 items. Is that?
I'm passing 2 arguments.
And to find non-digits, but aggregate digits is expecting 2 items as well.
Right, and that's what I'm doing. So there's that one.
Oh, I
and
got
then
you.
that
Sorry,
one.
I thought those were both in find.
Yeah, no, you're good. You're good. Let's see here. What's the joys of debugging? Okay, so if we go into find non-digit, this guy should be returning. Okay. Oh, I know why. Because this is I just needed to put in the index, not the whole thing. There we go. Okay, let's get rid of these breakpoints. Sometimes this debugger is a little finicky. No, what did I do wrong? I think it's got something to do with my slice. It's like not even registering my click. Sorry, one sec. Clear that guy. Nope. Okay. Debugger again. Okay. Okay. Okay, so here's our digit, okay, which is in this case 4. Let's go into our handle digit, which is here. Okay, cool. So that's going to push that into our array.
which if we look in the script, okay, there it is, beautiful. Okay, we'll step into our update view. Okay, we know that our, oh crap, I did actually need the, I did this part. I just shouldn't have, there we go. That's probably what was causing it. I needed to get the type. Okay. Okay. Okay, cool. Return value. Okay, sweet. Okay, so that return value should be, that should not be undefined. It should be in the worst case scenario, that should be a 0. All right, sorry guys. This is the life of a programmer. Good, beautiful, that's good. That's good. Let's make sure that our return value is what we expect. There it is, 0. Okay, cool. So then start and end. Okay, cool. That's what we want. There it is. Okay, okay, everything's fine. Everything's fine. So if I start clicking around, okay, beautiful. Sweet. All right, now, so the hardest part's pretty much over. All we have to do now is when I click on an operator, I need to be able to just add that to the array. And that is, you know, pretty simple. We just have to, of course, we just have to be a little careful, of course, when we are handling them. So we'll go down here. And in this case, we're going to do operators. And instead of handle click digit, let's go ahead and make a handle operator. Or what is it? Handle click operator. So here we go. So again, we're looping through our operators and we're doing our thing. Now, something I just realized is, you know, it may not be the most prudent thing to group this equals with an operator, because I would argue that it's kind of a special type. I would say it's a special type of operator. So what I'm going to do is I'm going to take this guy out for now. And we'll just put it in here for now, okay? Because it's kind of special. It once you click equals, nothing comes out of it. Or sorry, when you add it to equals, that's the end, right? We perform the magic trick. So I don't want to group it with the other operators. I'm not sure that makes the most sense, because for these guys, these are all going to behave essentially the same. So we've got to handle a couple of situations. So we'll go to our here. So again, we need to grab our operator, the actual thing. So we'll grab the name. So we'll grab the operator from the name of the button we just clicked. And then we will notice we're following a very similar pattern to our button or our digit situation, right? We're simply going to have to handle our data and we'll update the view. Not too bad. Okay. So let's do that. We're going to make a function called handle operator. And this will be our operator. And then we will handle our operator. And we'll pass in the operator. Cool. And then we will update the view. Okay, so let's just think about how this might work. So our operator, we need to think of a few situations, right? And we had already mentioned these earlier, which was one, we need to make sure that override existing operator, as well as not allow operator to start the array, right? We can't operate on nothing. And I don't want to make the assumption that if you put an operator in the first member of the array that it operates on like 0. Like I don't want to do any defaults or anything. Like I just don't want to allow that to happen. So we just need to do a few checks. So first of all, let's just check to see that the first one's pretty easy. So let's do this one. Let's make sure that if the data length is less than 1 or equal to 0, however you want to think about it, then we don't want anything to happen. We could throw an error, but it's not really an error. Let's just prevent the user from doing it. Or we'll just handle it somewhat safely, where you can't put an operator in if there's no data. Okay. Okay, now what we have to do is, again, let's grab our last guy. Okay, so we'll just say data and then data.length -1. This grabs our last item in the array. So if last.type is equal to operator, well, then we'll just simply replace it. We'll just say last.value is equal to operator. Let's put some. So pretty simple. If there's no data, then no problem. If it's already an operator, no problem. We'll just switch it over. For now, if since we're not dealing with modifiers or anything, we can always change the logic inside of this function. So for now, if it passes those rules, we're safe to add it. Okay, so we'll just simply say data.push, or sorry. Yeah, okay, there's some data, then return. Okay. So if there's no data, return. Otherwise, if it's an operator, replace it, and then we can exit the function. Otherwise, we'll simply say data.push. We'll make an object, type operator, and our value will now be the operator, right? This guy. Okay, so now what we can do is we can verify that this is happening. Okay, so let's go ahead and put a breakpoint here, and we're also going to put a breakpoint in this update view guy. Okay, so I'm going to click 3. Oops. Okay, so we just clicked 3. Okay, cool. Okay, now I'm going to click plus. Okay, cool. So it was able to go through our gauntlet of checks and check it out. All right, cool. So we'll go there. And then if we look at our data, we now have digits. Oops, sorry, our data is now a digit and then a plus sign. Okay, sweet. That's awesome. We can just check our circumstances. Okay, so if I do a minus, then I expect this to then override it. So let's go to here. So if I do a divide, right? So the last one's an operator. The last value that we had was a minus sign, I believe. And our new one is a divide. And if we click on number and look at our data, check it out. It's been replaced. That's awesome.
Just me and you, Ben.
Oh shit! Everyone bailed.
Everyone bailed.
It's probably taking too long.
That's all
I
right.
didn't realize this was gonna get so hard.
No, that's okay.
Tedious. Well, I can keep going if you want.
Up to you. I don't mind either way. I'm just having
I
fun.
think I feel like you probably know how to do this. So
It's always good to, I mean, get a refresher and get things abstracted away though. Because I mean, sometimes like you just get carried away writing stuff and you're like, oh, I should do the update view after my handle operator is done. But like just seeing other people do it who, you know, are thinking through problems different. You're like, oh, well, let's just return to break out of it. And if the data gets updated, well, it doesn't matter what the update view is doing. So, and then your reduce method, I would have never thought of doing like a callback to do something like that. So it's just really helpful to see different use cases.
yeah, that's definitely true.
Yeah, and your data structure is cool too, because I was originally thinking like, well, let's just do like a flat array, and then you're like, oh, well, we could declare types in there, and I'm like, oh, yeah, of course, because I was originally thinking like 2-dimensional arrays, and you're like, well, you know, this makes sense for a data structure. So it's just getting like the juices flowing in the brain. Personally, cool. Well, I'm pretty good about breaking stuff up. I feel like I would have followed a pretty similar flow to you, but just like seeing the way your brain ticks is super helpful.
Cool. Yeah, I'm glad I could help in that sense. But yeah, I mean, this is how you build a calculator. I think there are some tricky parts. Like, I mean, obviously, if we were doing something with like order of operations, that would be quite a bit more intense.
Yeah,
the way that you'd parse that array would be quite a bit more complicated.
Yeah, we'd have to build like some parenthesis delineators in there. And then like we can start on an operator if you're doing a square root. Like there's all kinds of like weird little use cases we'd have.
Exactly. But at least with this pattern using our array, we can add infinitely many types and infinitely many rules to handle those types that we want.
Which is super slick. And then you can base your rules depending on what type it is. And I never thought
exactly
of like that.
Exactly. Cool. Yeah. So that's kind of where I was going with that. Anyway, I feel bad that everyone bailed.
Well, I mean, to their
it may have just been over some people's heads.
I hope not. I mean, it's valuable stuff, but yeah.
Yeah, because like I don't know, like it's even if you didn't follow step by step, like I at least hope that people were at least able to take some like general concepts out of it.
Yeah, and I think the important thing here is like, well, just how do you logically break this up into pieces in your head so you can break it up into small pieces in your code, rather than like you said, trying to tackle everything up front all at once and getting carried away.
Right. For sure.
Well, I liked it. I like seeing how your brain works and how you break pieces off. It's super interesting.
Right on, man. Well, thank you for your valuable input as well.
Yeah, you're welcome. I haven't seen any of your lectures just because I'm so busy during the day sometimes, but this one was cool. I was
Yeah.
going to ask you, the
Yeah.
debugger stuff is something I've been really meaning to dive into a little bit more. And like, I understand your flow and stuff, but I don't use it very often. Did
Uh-huh.
you ever get that video recorded? I never even looked. I think they said
I
they were
think so. I think it's on the
on the vSchool.
vSchool site. If not, you'll have to bug Matt Mascarenas. Is that how you pronounce
That
it?
sounds familiar.
Yeah, you'll have to bug him if it's not on the vSchool YouTube playlist. There's like a playlist called Code Talk. It's a YouTube playlist. I think it's there.
Okay.
If not, bug Matt, or if you want, I can just show you some stuff.
I mean, I've seen
Either
some
way.
tutorials, and I know you're busy, so I don't want to bug you about
I
that
mean,
much.
I don't care. I love this stuff, so I don't care.
I know you do. Well, before I bug you, I need to get my hands dirty and actually start playing with it a little bit more.
Yeah, I mean, it's really simple. I mean, like literally everything I just did is basically the only thing. So yeah, everything I just did basically is the majority of all you need to know. When you get into like TypeScript, or any sort of like, if there's any sort of like build process or something where you have to use source maps, that can get a little bit tricky.
Okay.
You have to go to your um, you have to create like sometimes you have to update your launch JSON with some new properties and stuff.
Okay.
I think there's a source maps property. Yeah, source maps. Sometimes you have to
And
you just have to put in some more flags.
Okay, and that's just for like more static type.
That's when you
checking
have.
environments.
So, are you asking like when do you use source maps?
Yeah.
Yeah. So you need to use a source map anytime that your source code is being compiled into something else.
Okay.
Because otherwise you get weird stuff happening where like, because let's say this was TypeScript and it gets compiled into normal JavaScript.
Right.
Well, the line numbers aren't going to match anymore.
Right.
So the debugger needs to have a way of the reason why they call it a source map is because you need to have a way of mapping the code that's being run to the source. Because it could be on line 10,000 that the actual
Right.
things running in dev mode, like in your built dev code, but your TypeScript source, it's like line 100.
Right.
And so TypeScript will automatically generate the source maps and stuff for you. It's just that you have to tell your debugger, you kind of have to tell it about it. It's really really easy. You just put it in this configuration.
Gotcha. Okay. And I'm assuming it's the same way with React too, since React compiles those builds.
So in React,
not so much. Because it doesn't actually spit out a build folder when you're in a development environment in React.
So right, because it just uses an in-memory. It builds in memory, I think, for dev mode.
Okay.
And I think that it's practically already configured. I think anytime I've never had a problem with create React app using the debugger, because yeah, I think from what I remember, all I did was just, you just have to change that to the port that your dev environment's running on, which is usually 3000.
Oh, yeah.
And then I think you just add the source maps flag to this configuration, and I think it can just find it.
Okay.
And with TypeScript, I think it still finds it as well. Because if you're using like the TypeScript React template, I don't know if you've used that before.
I haven't. I'm familiar with it, but I've never.
Yeah, it's similar.
Okay.
I don't think that there's really too much to it, to be honest with you. If you're doing back end stuff though, you can't obviously use the Chrome debugger. I mean, you can, but obviously there's no website that you're going to.
Right. There's limited functionality there.
You're running a Node server, so if you're going to run your Node debug server, there's just a different setting. You go to your debugger, and then there's a pre-made configuration for Node. I believe it's just you just do launch program, and then you just put in. So if you're doing vanilla JavaScript, it's pretty self-explanatory. You just put the, that would be server.js or whatever it is.
Okay.
And
They're just the root of the whole server, huh?
Yeah, just wherever you're running your server from, so index.js or server.js, whatever it is that you call it. And then the debugger will work beautifully. Again, though, if you're using TypeScript on the back end with Node, you have to, there's a little bit more configuration you have to do. Especially like with your tsconfig JSON, you have to define source maps by default. And I think that might be it. I mean, I've done it several times, and it wasn't hard. I just had to look up a few things.
Okay. Yeah, not to prevent you from doing it. It's just like, oh, how did I do that again?
Right.
Okay.
Yeah. In fact, I think in my GitHub, I created a TypeScript little playground thing. Yeah. Yeah, here we go. Okay, cool. Yeah, here, I'll send you this link in Zoom. If it will let me, come on. All right, that repository is it's not a server, but it's a node. It's just like a node environment.
Okay.
So the same principle applies if you were using Express. You would it's just node. So
Gotcha.
this has Jest set up too with TypeScript, as well as it's just a TypeScript playground. That's literally what it's called. You
Okay.
can fuck around in there.
Cool. No, that makes
It has it all configured and stuff. So if you're using VS Code, it's pretty much, it should work just right out of the box.
Okay, sweet. And you just got to
You can kind of see like how I set up the VS Code configurations and stuff.
Perfect. Super cool. I'll dig into that. That's really helpful.
Yep.
Set up tests and everything too. Cool. Start your repo. Thanks. Got you a star, bro.
Nice.
Sweet. How's everything else going for you, man?
It's okay. Honestly. Long story short, I crashed my car last week. I had just bought it 3 days before.
Seriously?
Yeah.
Wow.
And like my girlfriend broke up with me, and I'm temporarily living in my friend's basement.
Yeah.
Not a lot of things are going right now, but that's all right.
It just means it's only up from here, right?
Yeah, exactly.
And you got a sweet dev job and you're helping people, so you're doing
something. Yeah. I try.
Yeah, no, that's always rough when life's not smooth sailing. I get it. Well, hopefully everything turns around for you soon, and
Yeah, I hope so. Yeah, how about you? How's COVID treating you?
It's COVID. I'm just staying indoors and staying quarantined.
Nice.
Taking that stuff pretty serious.
Mm-hmm.
Yeah, so I'm living with my mom, and she's vulnerable, so I don't really go and hang out with people very much, stuff like that. So just hanging out here in the basement and getting my social interaction through combos like this.
Nice. Yeah, dude. I know what you mean.
Yeah, I mean it's old, but I mean it is what it is. What are you gonna do, right?
Right.
Just kind of keep the chin up and keep working on something.
Faux show, indeed. Word, dude. Well, I'm gonna head out, but it was good seeing you.
You too, bud. Thanks for the powwow and catching up, and I'm sure I'll see you on one of these sooner or later. I'm gonna go grab some dinner.
Yeah, for sure. And feel free to reach out anytime. I'm not that busy. I'm not too busy to help. So
yeah, same here. I'm busy, but never too busy.
Yeah, I'm like literally just alone in a basement. So
hey, you and me both. Okay, I'll ping you if stuff comes up.
All right, man.
Okay, enjoy
Take it easy.
See ya.